So I welcome you all to a short video on DBMS. So in the last two videos, we have seen many things about the DBMS. That is the what are the basic definitions of DBMS and the file system versus DBMS. And next one, what are the data models available in the DBMS. So as the continuation of that, today we are going to see a new topic called DBMS architectures. So let's get into a video. Yes, sir. So the architecture, which is nothing but the how the DBMS is going to work. So there are mainly three types. That is the one-tier architecture, two-tier architecture, and three-tier architecture. So first we'll see what is a one-tier architecture. The one-tier architecture, which is nothing but a single-tier architecture. The structure of that one-tier architecture is the entire system, that is database, data DBMS software, and the application resides on a single machines. So all these three components will be in the single machines. Role: the user or designer works directly with the DBMS, making the changes instantly. Use case: preliminarily used for local application development, learning database concepts for the database administration. The drawbacks is no suitable for multiple users, real world or large scale environment. So this is called as your one tier architecture. The one tier, which is nothing but both your database and the DBMS software and the application will be on a single machine. And next one is your two-tier architecture. The two-tier, which is nothing but it's like a client and server mechanism. The main definition of this is the system can be divided into devise the system between the client one tier and the server two tier. The one tier is which is nothing but the client, that is the presentation layer, houses the user interface and the application programs. And the two-tier architecture, that is like a server, that is a data layer, houses the database and the DBMS software. The operation, the client communicate directly with the server using a API. Example, your JDBC and ODBC. Use cases suitable for small to medium departmental applications with a limited number of users. The drawbacks of your two-tier architectures are the security risk. The business logic rules often resides on the client side or is split, making data more valuable to unauthorized access or tampering. Scalability issues. The server must manage direct connections and processing for every client, limiting the number of uh, uh, simulations users it can efficiently handle. Maintains complexity. Updating the business logic requires updating the code on every client machine. So the next one is your three-tier architecture. The three-tier architecture, which is nothing but the presentation layer will be in the one and the API is in the other. That is, your application will be on the other, and the next one, the database will be in the another website, another site. The structure is introduces a middleware layer to separate application logging from the database. One tier user interface UE, example a web browser. This is all the user sees. Two tier uh, houses the core logic rules and produce. It act as the intermediate between the tier 1 and tier 3. And three tier houses the actual database and DBMS software. So the advantages of three-tier architectures are enhanced security. The client, that is tier 1, never communicate directly with the DB, that is tier 3. All requests are filtered through a application server. Tier 2, protecting the DB from direct attacker. Scalability, the application layer, that is tier 2, can be independently scaled, adding more servers to handle thousands of concurrent users. Next one is the improved maintainability, that is data independence. The logic update only need to be done on the application server, that is tier 2, not on every client machine. So this is the use case applications, that is the real world use case applications, that is tier 1, your SQL practice tools, personal database creations, and two tier traditional desktop applications with the office network local environment management. On the tier 3, online banking user. Tier 1 interacts with the website app. The website logic, that is tier 2, process the transaction. The database tier 3 handles the account updates. The all e-commerce platforms and large cloud services all comes under your three-tier architecture. So the next one is this is what we have seen how your DBMS versus this. The architecture chooses depends upon the application user base, scalability needs, and security requirements. The three-tier architecture is industry standard for modern enterprise applications due to its superior security, scalability, and maintainability. It ensures maximum separations of concerns by isolating the business logic from the client and the data. So these are the reference videos. If you have any doubt on DBMS architecture, you can refer these websites and have a more notes on that. Thank you, guys.